Today's lecture is about the VSEPR theory, valence shell electron pair repulsion theory, and with the help of this theory we can easily identify the shape of the molecule. The covalent bonding, the type of the chemical bond which is formed due to the mutual sharing of electron between two or more than two elements is referred to as a chemical bond, and further there are the much theories which completely explain on the basis of the covalent bonding the shapes of molecule, and one of these theories VSEPR, that is referred to as a valence shell electron pair repulsion model. So as far as concerned with the VSEPR theory, first of all we should know about the active set of electron. Active set of electrons. These are the active set of electrons of any particular central element that is present in one particular compound. So we can divide the active set of electron into the two major category. Number one, bond pair. Number two, lone pair. So first of all, it is very much necessary to learn about the bond pair. Then we will move toward the next postulates of VSEPR. What is the bond pair? The pair of the electron which is involved in the bonding. The pair of electrons that involve in the bonding. That is referred to as the bond pair. So we can easily identify this topic with the help of the certain example. For example, if we are dealing with the HCl. HCl having the single covalent bond with hydrogen and chlorine. So if we want to consider the active set of electron that is present in HCl, or if we want to identify the bond pair that is present in HCl, first of all we have to consider the valence electron in both of the element. Hydrogen atomic number 1s1 means its outermost shell is first, and that having the one electron in outermost shell or in valence shell. As far as concerned with the chlorine atomic number 17, electronic configuration will be 1s2, 2s2, 2p6, that will be 10, 3s2, 3p5, that will be 7. So total 17 electron present in the chlorine atom. And if we will consider what is the outermost shell of the chlorine, that will be third shell. And if you want to consider what are the total number of electron that is present in the outermost shell, the answer will be 7 electron, and chlorine is a member of the group 7 in the periodic table, so it contains 7 electron in outermost shell. So if we want to draw, let's draw the dot and cross model. So according to the dot and the cross model, which is actually the representation of the valence electron in one particular compound. So hydrogen with one electron, because one electron present in the outermost shell, that can be represented with the help of the cross, while the chlorine having 7 electron in outermost shell. So 1, 2, 3, 4, 5, 6, 7. So this is referred to as the pair of electron. The pair of electron which is involved in the bonding is referred to as the bond pair. So in HCl, one pair of electron involved in the bonding, that is why it is referred to as the bond pair. So this is under the example of the bond pair. Now we have to consider the lone pair. What is the lone pair? The lone pair, the pair of electron which is not involved in the bonding. The pair of electron which is not involved in the bonding. So here we can take the example of the ammonia. So first of all, in ammonia NH3, if we will consider the nitrogen central element, atomic number 7, 1s2, 2s2, 2p3. So valence shell will be second, and the total number of electron will be 5. So in nitrogen, outermost shell contain 5 electron in such a way that it utilizes its 3 electron with bonding with the hydrogen, in such a way that So in ammonia, nitrogen utilizes 3 electron with the bonding with the 3 other hydrogen, making 3 bond pairs. 3 bond pairs, and the pair of electron which is not involved in the bonding is referred to as the lone pair. So this is the example of the lone pair in the ammonia, that ammonia contain in nitrogen contain 1 pair of electron which is not involved in the bonding, while ammonia contains 3 bond pair. So as far as concerned with the identification of the shape of the molecule according to the VSEPR, one should know about the active set of electron. So if the first we have to consider the active set of electron around the central element. So first of all, we will take the example of the CH4, methane, the first member of the alkane family. If we will consider what is the central element in that particular methane, the one element to which all other elements are attached. So one carbon is attached with the 4 hydrogen. So carbon will be the central element. So first of all, the atomic number of the carbon is 6. We have to draw the electronic configuration in order to identify the active set of electron. 1s2, 2s2, 2p2, 2 or 2, 4, 5, 6. Valence shell will be second, and the total number of electron will be 4 electron. So now this carbon is attached with the hydrogen having atomic number 1, 1s1. So it contains 1 electron in outermost shell. Now we have to consider the central element carbon having the 4 electron, means we can easily identify these 4 electrons with the cross model, while that particular carbon attached with the 4 other hydrogen, and each hydrogen utilizes its 1 electron with the attachment of the 4 electron of the carbon. So here we can easily consider that how many bond pair present in the CH4 molecule. Here 4 bond pairs are present in the CH4 molecule. So if you want to consider the active set of electron, the total quantity of the bond pair is equal to 4, while the presence of the lone pair in CH molecule is 0, because there is no lone pair. So the total sum of the active set of electron will be 4. As far as concerned with the shape of the molecule, and if we are having the active set of electron 4, then always shape will be tetrahedral and angle will be 109.5. So in CH4 molecule in 3-dimensional space occupy tetrahedral pattern having 109.5 angle in such a way that hydrogen, 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 bond angle 109.5. So this is the tetrahedral pattern of the CH4 molecule. So all type of the molecule which are having the 4 active set of electron in such a way that the bond pair will be 4 while the lone pair will be 0, then it will occupy the tetrahedral shape with the angle of 109.5. So according to the VSEPR, or according to the presence of the active set of electron, we can easily identify the shapes of molecule. If we are having the active set of electron 4, in which number of bond pair 4, number of lone pair 0, the shape will be tetrahedral. That we recently studied this under the example of the CH4, CCl4, CBr4, C2H6. These all will continue with the tetrahedral shape. As far as concerned with the active set of electron 4 having the number of bond pair 3 and 1 lone pair, the shape will be trigonal, angle reduced 107. NH3, NF3 will be the example. And if the active set of electron 4, number of bond pair 2, number of lone pair 2, shape will be angular or the bent, angle will be reduced 104 degree, and example will be H2O, H2S. And if you are having active set of electron 3 in such a way that a molecule contains 3 bond pair with the 0 lone pair, geometry will be trigonal planar, angle will be 120, and BF3, BCl3, BH3, they all will contain trigonal planar geometry. And if active set of electron 2 and number of bond pair 2 while the lone pair of electron 0, then shape will be the linear, and its molecule that undergo the linear shape CO2, CH2, C2H2. So in today's lecture we only identify the shape of CH4 molecule, that having the 4 bond pair with the 0 lone pair. In further my next lectures, I will identify the shape of the CCl4 or other molecule, so you can easily learn with the help of these examples the shapes of the different molecule. This is the example of the AB4 molecule. A will be the central element and B will be another element that surrounded that particular central element, and it will occupy tetrahedral geometry.